In today's lesson, we're going to have a look at some Venn diagrams and two-way tables. Now, before we jump into some examples of this topic, we're going to go through some real basic terminologies that are really important to know before we step into Venn diagrams and two-way tables. Right? We'll start with some basic ones, and then we'll go into the more complicated ones. All right. Set. All right. We set is a collection of a group of elements that can include numbers, letters, or other objects. Right. So when we conduct an experiment, right, when I say conduct an experiment, it could be as simple as rolling a dice, right? Rolling a dice is going to give us options 1, 2, 3, 4, 5, and 6, right? We're going to work with this example when I go through these concepts, right? So the first thing, sample space. Sample space denotes all the possible elements. So in the case of rolling a dice, numbers 1, 2, 3, 4, 5, and 6 forms the sample space of that experiment. Right? Now, there's different symbols we can use for sample space. If you can't if you can't work out this one, this is the most common terminology used for sample space. It's like a curly-looking E, but if you can't do that, just use capital S as the symbol for sample space. Right, now the second thing, right, so Venn diagram. So we're going to talk about Venn diagram and two-way tables a bit later, right? A Venn diagram is just one way to demonstrate how all the elements in the sample space are distributed amongst the events, right? So when I say rolling a die, right, when we can talk about events being, right, the number of the odd numbers or the even numbers or a number greater than 3, number less than 2. All of these are examples of events, right? And a Venn diagram represents how all the events and the elements in that experiment are distributed amongst the events, right? So the first thing, obviously, the sample space is denoted by the rectangle. So everything in the sample space needs to go inside that rectangle, right? And the circle basically represents the events that we're dealing with, right? In the first Venn diagram here, there's only one event, which is A. In the second Venn diagram, we have events A and B. So we've got two events here, right? And I'm not going to go into too much detail there because we'll talk about it a bit later. Right, a null or empty set. Null or empty set is a set with no elements, right? For example, if you're rolling a dice, right, your options are 1, 2, 3, 4, 5, and 6. And I'm saying, what are the chances of getting an alphabet, right? That's not possible at all in that case. So that can be considered as a null or an empty set, right? Now, intersection. So all elements, if you're having two events, all elements that belong to both A and B make up the intersection. So in other words, there's keywords, two really important keywords that we need to consider when it comes to probability. And or, right? And represents the intersection, right? That's basically saying A and B. And the second one is or, which is given by A union B. So A or B is basically same as writing A union B. Right, now mutually exclusive events have nothing in common, right? They can't happen at the same time, right? Like, say, for example, in the case of rolling a dice, right, you can't have a number that's both odd and even, right? So we can call those events as mutually exclusive, which means they're not going to have any common elements between them, right? That's what we mean by mutually exclusive. So for a mutually exclusive event, there's going to be no intersection. That's why they've used a symbol for a null or an empty set. Right? Now, moving on, complementary events. Complementary events are basically the opposite. In other words, right? For example, odd numbers, the complementary of that is even numbers, right? There's a symbol we can use, right? We can use a different alphabet to denote that, or simply put a dash on top of that alphabet, basically denoting the complementary event. So the complement of A is given by A dash, which basically represents not A. Right, the next bit that's really good to know is the event and its complementary, right? They both add up to 1, so which is where this relationship comes into play. They're saying if you want to find the probability of a complementary event, all you have to do is you've got to subtract the probability of the event from 1. Alright, now let's look at some Venn diagrams and two-way tables. Now here is an example where they've drawn a Venn diagram and they've converted the same set of data into a two-way table. Alright, so in this case, again, there are two events in this Venn diagram, A and B, right? So let's look at some numbers in this case, right? So if I want to talk about the sample space or the number of elements in that sample space can be counted as 3 plus 1 plus 4 plus 2, right? Which is basically nothing but there are 10 elements. Oh, my bad. There are 10 elements in this sample space, right? And that's why all the numbers in that rectangular box counts up to 10, which basically makes up the sample space, right? The number 1, which is in the middle of A and B, right? That forms the intersection, right? A and B, that forms the intersection. Now, the number 3 basically represents the number of elements in just A and not B, right? So that's what here it's saying, A and not B, B dash. Do you see how they've used B dash, which is a complement of B, right? Similarly, the number 4 represents the number of elements in B only, or in other words, not A and B, right? Which is again what they've represented here with an A dash and a capital B, right? The number 2, which is totally outside both the circles, right, is basically the number of elements that neither A nor B. So they don't belong to both those events, and that's why they're outside the circle, right? Now the same information in the form of a two-way table, right? Two-way tables represented in this format. We have 2 events, right? A, right, and not A, right? And then B and not B, right? Now it doesn't matter which way they go. You can go A's on the vertical column and B's on the horizontal column, or A's vice versa, right? Now we've talked about the intersection. There's one common element between A and B, and that's what's going to go in that section there. So A and B, right? This element number 4 is basically not A but B. Not A and but B is 4. And then this one here is A and not B, which is our 3, which we discussed earlier. And then the number 2, which was totally outside the circle, is neither A nor B, and that's where it goes there. Right? That's why you can complete your two-way table. Right, that's enough theory there, right? I think let's jump straight into an example where we can actually draw a two-way table and a Venn diagram. Right, in this example, let's first read what information is given to us. So from a class of 30 students, right, that information is the total number of sample space. My bad there, sorry about that. Right, that's the total sample space. The sample space is 30 students. Right, 12 students enjoy cricket, 14 enjoy netball, and 6 enjoy both cricket and netball, right? So obviously in this particular example we're dealing with 2 events, right? Students who like cricket, students who like netball. Right, so the first thing I'm going to do is I'm going to first draw a rectangle that is going to represent my sample space. Right, so I'm going to say the sample space is going to have 30 students, right? That's a representation of the sample space. So I've just used capital S here. Right, we got 2 events, that is cricket and netball, right? So that's my circle for cricket, that's my circle for netball. Right, the very first piece of information, the best way to fill out a Venn diagram is basically starting from the middle, right? So which means, well, the first thing I'm going to look for is there any information that's going to be common for both cricket and netball, right? And that information's been given to us here, right? 6 students who enjoy both cricket and netball, and that's the first piece of information that's going to go in the middle there, right? So 6. Now if I just consider all the numbers that's been given to us in the question, right? So 12 enjoy cricket, 14 enjoy netball, and 6 enjoy both, right? Obviously if I add all the 3 numbers together, so 12 plus 14 plus 6 gives me 32. In reality we only have 30 students, right? So obviously there are going to be some students who have some common interests, right? At the same time there could also be an option where there could be some students who might not be interested in both, right? And that's what we got to figure out by filling out the rest of this Venn diagram. Right, now let's start with the cricket part. Right, 12 students enjoy cricket, which means the total number of students in that cricket circle needs to be 12. Right, now if I consider this cricket circle, I already have 6 students in that cricket circle because there's a common between cricket and netball. Right, so out of the 12, 6 students have already been taken. So how many are left? The 6 students left. So 12 minus 6 gives us 6 students who like only cricket. Right. And then similarly, if I talk about netball, there are 14 students who like netball. Now we already used up 6 in the middle number, right? So which is why, so 14 minus 6 gives us 8 students who just like netball, right? Now if I add the 3 numbers that's been given to me there, so 6 plus 6 is 12, 12 plus 8 gives me 20 students. Now we know there are 30 students in this class, right? So where's the rest of the 10 students, right? These 10 students are the ones that neither like cricket nor netball. Right, and that completes the sample space. The best way to check your answers, you've got to make sure you add all the numbers in your rectangle, and they need to add up to the total number of sample space. Right, now if I want to represent the same piece of information in a two-way table, right, so the first thing I'm going to do, I'm going to just quickly draw up a two-way table. Right, now again, like I said, it doesn't matter which way you go, so I'm going to put cricket on the top, so cricket and not cricket, netball and not netball. So we're going to represent the complementary. Now we know the total number is 30 students, so we need to have a total of 30 at the very end. So let's start again. We're going to start again from the middle, right? So which means 6 students enjoy both cricket and netball. So cricket and netball, that number is going to go into this box. That's the cricket and netball box. Now 12 students enjoy cricket, so 12 students are going to enjoy cricket, so the total number for cricket is going to be 12, and 14 students enjoy netball, so the total number for netball is going to be 14. And again, we're going to do the subtraction side, so which means the remaining number that's going to go into this box here is 12 minus 6, which is going to give us a 6. Right, similarly on this box, 14 minus 6 gives us 8. Right, now if I take into account some of the other boxes there, right, which we can further fill out, right, there are 30 students in there, so which 12 students like cricket, so which means 18 students do not like cricket. Similarly on the vertical column there, 14 students like netball, and there are the 30 students, which means there are 16 students who do not like netball, right, which also helps us fill out the missing box in the middle there, right, so that's going to give us, right, so 16 minus 6 or 18 minus 8, both should result in a 10, and that's the number of students who neither like cricket nor netball. Right, and that completes our two-way table there. Right, so in this two-way table in the Venn diagram, we've taken into account the number of students. Right, so that's the first example I want to discuss. Right, now there could be any number of questions they could ask from here onwards, right, where they could ask us to find the probability. Like for example, they might say, right, what is the probability? There's two ways the questions could be asked. They might just say, what is the number of students who let's use a different alphabet, so who like cricket and not netball, right, so we can look at both the diagrams and see there are 6 students who like cricket and not netball, so that could be just 6. If the same question is written in the format of what is the probability of cricket and not netball, that's basically going to be 6 out of 30 students, right, which simplifies as 1/5. Alright, so there's two ways the questions could be asked. Sometimes they might just ask you for the number if they use a lowercase n. Sometimes they might ask you to find the probability. Right, so when we find the probability, it's the number of favorable outcomes divided by the total number of outcomes, right, which is what I've done there. Alright, so let's move on to a second example, right? So here we are dealing with a class of 35 students, right? So that gives me my sample space of 35 students. Right, 6 students like all 3 subjects. So all 3 subjects, that straight away gives me, this is the Venn diagram situation, or this is an example where we're dealing with 3 events. Right, and the 3 events we're dealing with are PE, science, and music. Right, so 8 of the students like PE and science, 10 students like PE and music, 12 students like science and maths, and also 22 students like PE, 18 students like science, 17 like music, 2 students don't like any of the subjects. Right, lots of numbers, right? Lots of numbers, and obviously if you add all the numbers together, definitely giving us a number more than 35, right? So which means there are some common elements between there which we need to unpack. Right, so again, like we did in the previous example, right, we're going to start with the center of this Venn diagram. So here I've just drawn a Venn diagram here. The rectangle represents the sample space. We've got 3 events, PE, science, and music, right, now interlinking into each other. So I'm going to first start with this part of this Venn diagram, which is the very center, right? The very center is where we're going to start this particular question with. That center basically represents the number of students who like all 3 subjects. And that information is being given to us here. Right? 6 students like all 3 subjects. I'm going to put that number in there straight away. Right, now let's go to the second part of this question. They're saying 8 students like PE and science. So PE and science, right? The PE and science basically represents this particular part of this Venn diagram, right? So that's the section that includes PE and science, right? They're saying 8 students like PE and science. I already have 6 written in there straight away. So which means how many students am I left with? I'm left with 2 students, which is the number I'm going to put in there. Right, similarly, we're going to deal with the next information that's saying 10 students like PE and music. So if I take into account the PE and music bubble, right, there's 10 students there. I already have 6 written, so which means there's a remainder of 4 students. Right, now let's move on to the next part of this question. 12 students like science and music. 12 students like science and music. I already have 6 in that common bubble, right, giving us with a remainder of 6 students. Alright, now let's move on to the next part of the question. They are saying there are 22 students who like P. Right, 22 students like P, which means the total P circle needs to have 22 students in them. Right, let's go into the circle, P circle. I already have 4 plus 6 plus 2, which is 12 students in the P circle out of the 22. So how many am I left with? 22 minus 12, which is going to give me 10 students. Right, the second part, 18 students like science. 18 students like science. I already have 6 plus 6 plus 2, which is 14 students. So I'm going to be left with a remainder of 4. Right, and finally we have 17 students who like music. Right, 17 students who like music. I already have 6 plus 4 plus 6, which is 16 students, leaving us with a remainder of 2. Now in this particular example, they've been actually really kind to give us this last piece of information, right, which is 2 students who do not like any subjects. In most cases, right, they don't give us this information, right, and the way they expect us to find this information is basically by adding all the numbers in the Venn diagram that we have so far, right. So if I have 10 plus 2, 12, 12 plus 4, 16, 16 plus 6, 22, 22 plus 6, 28, 28 plus 4 is 32, 32 plus 1, 33, right? We have a sample space of 35 students, right? Obviously there's a remainder of 2 students who are not fitting into any of the 3 circles, and that is what's going to be the number that is going to be falling outside the circles in that Venn diagram, giving us a total sample space of 35 students. Right, now let's move on to some questions here, right? They want us to determine the probability that a student likes PE only. So which means the probability of PE only, right? So let's look into the PE circle, right? There are some common bits that is part of other circles. The only bit that's common that's only PE is number 10. So that's going to be 10 out of 35, right? Which simplifies as 2 on 7. It's really important we simplify fractions. Now we're looking at the second part of the question. They're saying we're finding a student who does not like music, right? So which is basically all the elements that is outside the music circle, right? So all the elements outside the music circle, that's basically your 10, then you have the 2, 4, and then the 3, right? So if you add them all up, so 10 plus 2 plus 4 plus 3, so that's 12 plus 7, which is 19 students. Right, so probability that the student does not like music, right? I can also represent it as M dash, which is not music, right? Complement, we talked about it earlier. 19 out of 35, right? 19 and 35 don't have any common factors. Leave it like that. That's the most simplified answer. All right, this next question here, there's 3 parts to this question, right? Find the probability, right? Science, union, music, and then intersection P. Right? If I want to represent this particular question in the form of words, we're basically saying what is the chances that the student is a combination of science or music, right, and not P, right? There's a dash next to the PE. So that's the representation of this question that represents this particular question, right? So science or music. So science or music basically is all the numbers that's inside the science and music circle, right? So let's talk about this. How many numbers? So let's add the science and music part of this. right? Science and music is all the circles, right? And not PE. So the only part which is common to PE in the science and music circle is basically anything that's falling in the intersection there, right? That part is PE, right? So which means the numbers that are science or music but not PE are 4, 6 and 1, right, which gives us a total of 11, right? So that's going to be basically is equal to 11 out of 35, right? So it's really important that you read these questions as carefully as you can, and that's going to make it easier for you to work out the probability for this question. All right, so I'm just going to highlight that in yellow so that way we can see what I've highlighted in the Venn diagram as well. All right, and that completes our lesson for today, right? I know it's been a long one. Thank you for listening, and have a wonderful day.